Thanks, Nicole. Yeah, so I'm going to this is kind of a high-level tech talk on on-chain art NFTs. So intro to on-chain art NFTs. Yeah, so like maybe when people see this title, they might be a bit confused, or maybe they're not at all, but some people might be because obviously NFTs are on-chain. It's a non-fungible token on the Ethereum blockchain. However, all the stuff that we've come to know and love about art NFTs, like the picture, and I love Crypto Coven, so like the witch's name and her description and the properties, all that stuff actually lives completely off-chain. And in a lot of cases, on like normal Web 2 API servers. In other cases, other decentralized storage, more like Web 3 approaches like IPFS or Skynet or Arweave, and all of those solutions, which is a feasible solution in a lot of scenarios. Putting things on chain is extremely expensive, and for good reason. When you put data on chain, not only does it cost gas, especially a huge picture, right? That's the big bottleneck. But every node that runs the Ethereum blockchain has to replicate all that data. So putting pictures on chain would cause, a lot of bloat. So what is on-chain for these art NFTs? All of that is on-chain is the logic that pertains to ownership, what address has access to the NFT or has rights to do certain things with it or owns it. Yeah, but today we're going to talk a little bit about how to put art on-chain, because when it is off-chain, we have the ownership aspect on-chain, but if all that other information that explains all those NFTs, if that information gets lost, like, what do you even own anymore, right? So it's a bit of a vulnerability, but yeah, so let's talk about some creative things people are doing to put some art on-chain. Really quick, my name is Emily Williams. I work at Uniswap as a software engineer. Have some socials there, and a picture of me. I don't really like to pose for pictures, so that's kind of the only picture I have. But yeah, so all of this stuff that describes an NFT that you see on OpenSea, the title, the picture, that's actually part of the ERC 721 optional metadata extension. So for the technical spec, it's actually not even a main component. But obviously with art NFTs, it's become like the meat of what an NFT really is. So this is the implementation of the optional metadata extension. And you'll see token URI is really where all that metadata comes from. So everything you see on OpenSea, the picture, I'm going to refer to that as metadata. And what the blockchain returns in most cases is this base URI and then maybe a token ID appended. And so the blockchain has a link on it, but it just is pointing to something external. And that's where all the art lives for 99.999% of NFT projects. And so a popular NFT is POAP. You may have gotten a POAP for attending an Ethereum event. And this is kind of like an arbitrary data token URI for an arbitrary POAP. And so the metadata extension will return JSON. And kind of the important components here, like the name and the description and the image. And then like all the properties and attributes and stuff like that. But how do we put this on chain? And that's what this talk is about. So there are kind of two main, I think, components that we can switch up to get this stuff from external servers to on-chain. And one of them is using data URLs instead of links that point elsewhere. And the other is SVG formatted images that can be efficient enough to store on-chain. So first, using on-chain data URLs. A data URL is a URL that instead of pointing elsewhere, it actually has all the information inside of it that is needed to render, for the browser to render it. And so these are two examples of a hello world data URL. If you plug that into your browser, you'll see hello world in plain text. This is base64 encoded. It would render the same thing. On-chain, most of the time we use base64 encoding for this. And then the other component is using on-chain SVGs. SVG is an image format that uses HTML syntax that a program can read to render the image. Here's a little code snippet. This is a blue square, and so instead of having all those pixels stored, it's just like a simpler HTML. The other great thing about SVGs is that it's really easy to layer them on top of each other, so a lot of these projects kind of deploy a lot of different SVG components, and then when we put the unique NFTs together, we kind of layer them on top of each other to make unique images. So I quickly want to go through about 4 projects that have done distinct implementations. It's kind of tough to fit into 20 minutes, but we're going to try. I might talk a little fast, but just super high-level technical overview of a few different projects. So obviously the first one I want to start with is what we did at Uniswap with our on-chain NFT metadata. It was my first project at Uniswap, and it was really fun. And so this is the image of it on OpenSea. We kind of inject a lot of financial information about an NFT liquidity position on our protocol. So if you provide liquidity into Uniswap, you get an NFT that claims your ownership if you ever want to come and claim your liquidity back. So it actually didn't even really need this optional metadata extension that the art ones use, just like the main technical spec. However, we thought it would be fun to go in and add that. So yeah, I talked about this token URI and what we typically return. However, in our code, instead of returning a base URL and a token ID, our token URI function calls into this function called construct token URI. And from the token ID, we can get all the parameters from your financial position and then inject it into some JSON. It's kind of like Mad Libs. We kind of posted like a format for the JSON and the image and then put your specific data in it. So, you know, we put all of the financial information, and you can see down here we're starting to form that data URL that you see instead of an external link. And the images are also links. HTML expects a link for your image, and that can also be a data URL that represents an SVG. So when you plug that into your browser, our huge data URL that you return, you get this JSON. You don't really need to read this, but it's just like kind of an example of what a big data URL looks like. They're big and they're ugly, but they have all the information that you need to render what you need to render. This is base 64 encoded, our image. You know, so you can see the image is like the big part of this metadata extension, and it's why it's hard to store it on chain, where storage is super valuable and expensive. Yeah, and so when OpenSea gets this information, this is what they render for our position. What else? Oh, here's a few more from all different pools. Depending on the pool you're in and the tokens, it displays a different color, and the curve is unique to your position if it's like flat or more curvy or whatever. And so, okay, let me go back here really quick. A lot of people ask, or a common question is, well, isn't it so expensive to mint an NFT if you're going to be putting all that art on? And the answer is no. A lot of the upfront heavy lifting happens on deploy. Everything's deployed, and then the user kind of can store certain information to get access. And I'll talk a little bit more about that with another project. But in our code, we just have a bunch of SVG lines, and it's super ugly because Solidity wasn't really made for this. So yeah, it was just kind of challenging for many different reasons. My linter broke. I had to get in touch with the linting team because it didn't even understand what was going on. But yeah, so all of this is stored up front, and you can see like all the images are, all the images, actually I don't remember what I was going to say, so let's move on. And so to put the information into this big SVG function, when we're forming that data URL, we call generate SVG image, which then we can inject all of that like financial information that we saw that was baked inside the image. But a little more fun, we also wanted them to be colorful. And so how do we put the colors or determine the colors on these NFTs? And what we did is in HTML, a lot of times colors are represented as 3-byte hexadecimal. And conveniently, Ethereum addresses are also represented as hex strings. So we just took the token addresses from the pool and took snippets from them to then make the colors for the NFT, so each pool had unique colors. But then so that each NFT was also unique, you can see we kind of have like this tie-dye background. So that each one was unique, we also used the token ID, since that's like the unique aspect of each NFT. They all have a unique token ID, and use that to generate how those circles would be laid out so that that kind of tie-dye layout was unique for each person. Really quick, this is the function that did that, but you can just, the slides will be available. Yeah, and so that's the Uniswap one. And then another project I want to talk about was Animal Coloring Book. Wilson works on a lot of NFT projects where like the image will change depending on how you're interacting with it on chain. So in this project, an image gets built as the NFT gets transferred to different owner addresses. And the new owner addresses determine the future colors and the personality of these images. So when you first mint, it's a blank slate, but then as you transfer it around to different addresses, the first 4 transfer addresses, the new owners get saved in storage, and later when we're going in to extract the image, it looks at those addresses and just like similar to what we did, uses the hex strings to determine colors. Yeah, and so let's talk about another on-chain NFT project. I also got to work on this one. This one's called Shield, and in this project, you get to mint yourself a build pass. So when you first mint your NFT, it comes up as this build pass, and if you're the owner, it gives you the right to then build your own custom shield. All of these shields that I'm showing right here were all rendered from the Ethereum blockchain, and they were customized by shield holders. And the way that we did this is we deployed there's 3 layers. Like we talked about layering SVGs. There's this background, and then the hardware, which is this metal-plated object, and then the frame. And so we deployed all of these components on-chain, and then the users get to pick their colors, their background, and objects, and then it kind of gets layered together for each unique NFT. And not only that, but the title would also be generated dynamically depending on what colors and all the attributes that you chose for your shield. So all of that kind of gets generated when you call the token URI view function. It does a lot of work to go collect all these layers and then render it for the user. So, like I said, storage is really expensive, and I think we deployed about 500 SVG images in total for all those layers, and it ended up being a deploy cost of about 24 ETH for all the SVG contracts. You can kind of see this is a directory with like all the contracts for all the SVGs that we had, and it was a little ridiculous. But yeah, but because it's so expensive to put this stuff on chain, we decided to make it super easy to interact with these contracts, that if people want to use these for other projects, those images are already there and it's Creative Commons. It'd be fun if more projects did this, we can kind of mix and match and make like endless amounts of cool SVG art on chain. And this is just a picture of one of the SVG functions that you'd go get. And I just wanted to illustrate, we had to optimize the hell out of these SVGs, and it was super tedious for the design team. They spent so much time getting these SVGs as small as they could that they eventually turned into something that was pretty not human readable. But yeah, so that was an interesting process. And also we store them in the functions of the contract instead of storage because it's just cheaper to do it that way. And so when you build your new shield, like I said, you're not deploying a new image to the blockchain. It's actually really cheap. All you do when you build your shield is you choose an index that corresponds to the background and to the hardware and et cetera. So this is like a shield struct. And so really the user, when they build their shield, is only storing roughly like 160 bits of data, which is cheap, despite all the cool stuff that it does. The bulk of the work is done on the deploys for all of these projects. Then I wanted to talk about one more variant of on-chain SVGs, which is on-chain pixel generative art, which renders these images pixel by pixel. And this is another approach that a lot of projects have done. It kind of evolved at the same time as this SVG layering I was talking about. There's a lot of cool projects. I have 20 minutes. I can only focus on one. I have no idea how I'm doing on time, but I'll just keep talking fast. So I'm going to focus on chain runners, which is this green guy right here. Chain runners, when minted, code uses the arbitrary data from the mint transaction to construct the chain runner DNA, which is a 256-bit integer. And then the DNA gets split up into 13 different parts to determine the different attributes of the chain runner. And by attributes like the hair, the eyes, the nose, the lips, like whatever. So yeah, these are all the layers. And so here's a few that like all have this green hair, or all have these glasses, right? Everything gets mixed and matched generally with on-chain art. So here's the minting functionality. When you mint, it takes your token ID, the sender address, some arbitrary stuff to make a pseudo-random number that's going to determine what your code runner is going to look like. which is super cool because like when the team deploys the contract, like no one knows like as it gets minted, like what these runners are gonna look like. It's completely up to like this cryptographic hash, which is kind of fun. And then, so like I said, that we have this huge number that gets split into 13 parts. And then when you take your snippet of DNA, say for hair, and then to determine which like hair you'll have, they have these weights arrays with a race index and then the layer. So they have like a human, a bot, and something else. So this is a human, and this 0 might be hair, 1 might be eyes. And what it does is it loops through these weights. It basically moves a range up the scale of numbers until you get to the max uint 16. And then as it moves up, it sees if your number falls within that range, and if it does, that's the attribute that you get. So it's a really cool way to put the distribution across, and you can make things more rare or less rare with these weights arrays, which is pretty cool. This is all the weights arrays. It's like daunting to look at. This is in the constructor of the contract, and all of this kind of gets put to storage. And what else? And then the other thing, so not only did they have to deploy those weights, but then the layers. So after they deployed the contract, then there was some follow-up functions that the owner could do to get all of these different layers on chain, which they did in storage, which is a little different than me, which everything was in bytecode. And then the layer is just like really a bitmap. And then they have a function that can decode it and then like put the pixels in the image, and also the name. It might say green hair, and then the bitmap to decode for the pixels. And then just to compare with shields, to deploy chain runners, they deployed the contract, did the constructor, put all those weights on chain, or sorry, in storage, and then uploaded all the layers, and that was about 7.5 ETH, which was 34K at the time. So these projects are super expensive to deploy, but they're super fun, and you know, when you mint, it kind of, there's a mint cost, so the deploy costs, I think, do generally get made back. Okay. Oh, I'm doing really well on time. Okay, well, I could have talked about other stuff then. I cut so much stuff out because I didn't think I could fit this in 20 minutes. Once again, here's some different pictures of chain runners with all the different attributes. And then when you do pixel by pixel, the SVG kind of looks like this. I actually took this from the CryptoPunks contract, and CryptoPunks subsequently also did an on-chain version of their SVGs as well. And I actually, it all really goes with layers of attributes, but there was this one attempt to do CryptoPunks before like the layering, and what this guy wanted to do, 0xDef Beef, I credit him later, but what he did is he deployed the first 500 punks, and then he subsequently, for all the rest of the punks, found the one that was most similar to the one he deployed, and then rather than deploying the data for every single punk, he would deploy like the delta, so like for the subsequent punks, find the one that's most similar, and then he just stored all the pixels that were different from that punk to try and like cut down on the data on chain. So I just thought that was kind of interesting and kind of a unique approach, so I wanted to mention it. The CryptoPunks official team took inspiration but ended up doing a more of a layering approach like we saw in chain runners. Advantages of on-chain metadata. I shamelessly took these bullet points straight from this blog post, which is a really great blog post if you're into this stuff. Recoverable, an on-chain NFT is one that can be recovered entirely from the data on-chain on the Ethereum node. You know, you're depending on the security of Ethereum layer 1 instead of like having to spread your dependencies across like other protocols and like IPFS and et cetera. You're depending on the security of many protocols instead of one, or a centralized server which could just go down any day. Or they can change them any day. Most projects, like if the team wanted to, they could change it, but they don't because they have integrity, right? But I don't know if that's how this is supposed to work. Summonable, an on-chain NFT that can be put to use without any further processing directly on chain. If that metadata has anything to do with doing stuff on chain, it's available. Composable, an on-chain NFT that can be easily manipulated by other on-chain components, such as other contracts, in order to integrate, extend, or modify. And then And then evolvable, an on-chain NFT that is dynamic and changing with the chain over time. I showed you animal coloring book Wilson has done, other really cool projects that kind of gamify how you move the NFT around the chain and how it will render based on that. And those are always really fun and really cool. Acknowledgements and people who helped me with some ideas for this talk was Simon De La Rouvier. You should definitely follow him. John Palmer and ZeroXDefB for talking to me about his CryptoPunks implementation. Someone should make chain punks. And here's some cool resources if you're interested in reading up on more of this stuff. Maybe I can post a link to the slides in my bio, so you could just look for it, and I'll try and get a link there, or you can take a picture. But I think that's the end of my talk. I can't believe I did that in 20 minutes. Yay.
Thank you so much, Emily. We have time for questions. Briefly. Any questions?
It's okay.
All right, I will come to you.
Q&A is scary anyway.
Sorry if you explain this. So maybe you have to explain it to me like I'm a kindergartner. But in the music world, a lot of pieces of sound are built in libraries, then kind of composed. Do you see that happening on chain so that every project doesn't have to deploy aspects to the chain, but rather there becomes just massive libraries that you can pull from and compose from?
Yeah, I mean, ultimately, if we want to put a ton of stuff on chain, I don't see any other way of doing it because, obviously we don't want to blow the chain. There's lots of scaling solutions. I mean, maybe layer 2 will be good for this stuff too. There was one music NFT project which I thought was weird, and they put the little, I'm not very good at knowing the technicalities of music files, but just like an A flat at a certain, it's been a long time since I've been in Ableton or anything. But you have the sawtooth curve, an A minor, he just put all of those different ones on chain. And I thought that was interesting because then people could go and pull those to make songs. I know there's some people in here who are really into music NFTs. I can see them. I have less experience with them, but I'm sure that there's going to be a lot of cool stuff to come from that. But I'm actually not super up to speed on all of it. But the one I'm talking about is Bleep Style or something, where he put all the different wave sounds for little tiny E, A minor, all that stuff on chain, or A flat, whatever. But yeah.
Thank you so much. Everyone give it up for Emily Williams.